Alright, so I'm going to go ahead and give the lecture of area between two curves, just for those of you who need a little more time and really want something to do on your third snow day. So if we look at this very first drawing, this is what we've been doing so far for area, is this shaded area right here. We did it as if these were rectangles and said, okay, well, that rectangle is going to be delta x wide and f of x high. And so we put that in our integral, and all this integral thing does is add things up. That's all it does. And so we're adding up length times width from A to B. And so that's our area. So the question comes, not from that one, but the second one that's drawn here, is how do we find the area that is shaded in green on this second picture? How do we find that area? And so if you're looking at it compared to the very first one, you should say, hey, well, it's really similar if you just subtract out that thing right there. And that's a box, okay? And you could actually go find the area of that. That area would be C high and B minus A, whatever that is, wide, and you subtract that. But if we wanted to do it in terms of area, we would say, all right, it was our original integral, a to b of f of x dx. That was the whole thing, the entire thing. And then we would subtract out the area of the red box, which is from a to b of just c times dx. And this b minus a is really that delta x, that dx. And then c is your height, and we're just going from a to b. Those are x's. And so that's how we would find the area between those two curves, is just to subtract out the bottom part. Well, something about integrals, the way that they're written, and we've done it one way, and we're going to go back and do the reverse, is if these two integrals have the exact same interval, they both do a to b, you are allowed to combine them and do a single integral. So this would be f of x minus c times dx. First power, we could separate them out and do them as two different things. So in other words, when we did, let's say, this antiderivative up here, I said, okay, guys, really, you can write that as x squared dx plus the integral of 3 dx, because you're taking each antiderivative separately anyway. And so that's how we can put this together. And so we're going to do a little multiple choice to see what are the different ways of representing this area. But what I need to get across to you is when we find this area, the base, the width of our rectangle is always going to be our delta x, our dx term. That's why that always has to be with the integral. But the height term is going to change. And so it's going to change depending on what functions you're using, but what's always common to it for area is always the top minus the bottom. Right? And so if you look at this function that we just did with the shaded green area, we came in as the top is f of x and the bottom was c, and we took f of x minus c, so that matches. Then you ask, well, why haven't we been doing that the whole time? And we really have. Is that if we look back at this first graph, the bottom is the x-axis, which is 0. And so we've been taking f of x minus 0 this whole time times delta x. We just haven't shown the 0 because it's kind of redundant and ridiculous to show the 0. So then we're going to look down, just a multiple choice, and look at these possible integrals and see which of them will correctly express the area between f of x and c, that green shaded area. So we're going to look at them and just go one by one to see if they work or not, and I'll put a check mark next to it if it works and an X if it doesn't. So if we look at number 1, that is exactly what we wrote up here for the area. That first integral is a to b of f of x dx minus a to b of c dx. That is the whole area minus the little rectangle. That works. Option 2 is the second thing that we wrote. It's just saying, hey, we've got two intervals that are identical. We can combine them together. So that also works. So now we move on to 3, and so here's where it gets tricky, 3 and 4. So if you look at 3, it looks very similar to 2, except for c minus f of x has been flipped. Well, if you flip that, you're going to make it negative of what it was before, which is not right. But you have to notice something else, the a and the b were flipped. that also makes it negative of what it was before. So we flipped two things, and they both change the sign of it. Well, if we have two negatives, that stays the positive. That also works. If you change one thing, you're going to change the sign of it. If you change two of the signs, it's going to stay the same sign. So let's look down at 4, and we kept the c minus f of x that was up in number 3. We have a to b like was in number 2, so that hasn't changed. But there is a negative out front. So once again, we have two negatives. That makes it positive. So all 4 of these options actually represent that area correctly. And so it's not that you'd have to write all 4, but you have the option of writing any one of the 4 and being correct. And in a multiple choice situation, you have to be aware of any one of these can be written. You just have to assess, is it going to correctly give me a positive number for area and represent that in that interval? Alright, so we're going to move on and just look at some pictures, and I'm going to ask you, how would you write an integral expression to represent the shaded area? Alright, so if we're looking at this first picture, this shaded area is in between. And so if you look at it two different ways, you can say, alright, I'm going to find the whole area under the blue f of x curve. And then I'm going to subtract out the area under the y equals x curve. And that'll be the green curve left over. Well, if I write my integrals for that, the area under the f of x curve is a to b of f of x times dx. And we're going to subtract out the area under the y equals x, so that's still a to b. And it goes of just the x times dx. What we talked about up before is if they have the same interval, we can write them in a single integral and have f of x minus x times dx. What I want to get to is where we can write this automatically. And so if we look back at this problem, instead of the whole minus a part, we can just say, okay, what I'm really going to do is I'm going to make a little rectangle in here, really small, but this is delta x, and this distance right here, how you would find that is take this top number, which is f of x, minus the bottom number, which is x. So this distance right here is f of x minus x, this y right here, and that's your base times your height, and that's what we're doing. It's no longer 0 as your second curve, it's actually a function. So we're going to do that with this next curve. Alright, so on this next curve, we have a part that would be negative at first glance. From this point, let's call it C, over to B, that would give a negative answer. And we can't have a negative area. There's no such thing. So what we're going to do, we're going to write our first integral. And that goes from A to C, and it's already positive, so we just write f of x. And it's technically minus 0, because it's top minus bottom. That's what we're doing, is putting a little bitty rectangle in there. Okay, you do not have to write the 0, but for the purposes of what we're getting to today, I want to go ahead and write that in there. And then we want to add, and this next integral has to represent this shaded area, but we need to make it positive. So there are many ways you can make it positive. You can put a negative out front. You can flip the order that's inside. And so I'm going to show you a couple different ways of writing this. So if we just continued to go left to right and went from C to B, the top curve now, with our little rectangle, is 0. Over on the left, the top curve is f of x, and we could write f of x minus 0. But on the right curve now, it would be 0 minus f of x. So that works. Top minus bottom will always, always, always give you a positive number. And so if you doubt this at all, and you're like, but no, f of x is going to give me a negative here, if f of x, let's say this came out to be negative 1 down here, this function right here would be 0 minus negative 1. And it would definitely give you a positive number there. So if you will trust the top minus bottom to give you a positive number, it'll work every time. So the other way you're going to see this written, you go from A to C of just f of x dx, plus we can get rid of this minus in front of f of x, because most of you won't write the 0 every time. Okay, if we want to make it just f of x, we want to make it f of x minus 0, we're going to go from B to C. We're going to flip the interval around. We're going to read right to left, which changes the sign. And this is f of x dx. These are the exact same integrals, the setups, or whatever. It's just changing who's positive and who's negative to give us a positive answer for it. Alright, so the last one, We're going to do the top minus bottom purely. Okay, we're going to do the area shaded in green. So we're going to look at this first section. Okay, and this interval is from A to C. And if we do that, if we write from left to right, A to C, we have to do top, which is f of x, minus bottom, which is g of x, and times dx. So all we're doing is put a little rectangle in here, and that's delta x, which is dx, and the top curve is f of x, and the bottom curve is g of x, and we're subtracting them to find that distance. So that gives us the first section, and if we want to do the second section, we read left to right, we go from C to B, and our top curve is now g of x, and our bottom curve is now f of x. Okay, so those will both give us positive answers, and that's what we want. Now, if we just had to set that up, that's wonderful. If you actually have to work this out by hand, which means you want to integrate, you would love for these two to be the exact same thing so that your antiderivatives are the exact same thing, and you only have to take one antiderivative. So let's say we wanted to just do f of x minus g of x, we'd have to make a slight change to the second one. Okay? If we're going f of x minus g of x, on the second integral, since we flipped one thing around, we flipped our integrand, that's what it's called, around, we're going to have to flip something else around in order that we don't change the sign of it, so it gives us a positive answer. So instead of going from C to B, I can go from B to C. That's not the only option. You can put a negative out front here. But these are identical integrals. It's just that now if we had to work this out by hand, that and that are identical, and we would only have to take one antiderivative. Alright, so there is a general set of steps that you're going to use to find area between two curves. And this is exactly what we wrote down the other day that I was using to find area with a curve in the x-axis. It's identical, it's just I'm going to change the second curve from the x-axis to another function. And so this is a lot more condensed than the list that I gave the other day. It still has all those same steps. It's just I didn't give it in as much detail. So first you're going to set the two functions equal to each other. Why that's important is you're going to find out where they cross. And that's what we've been looking at up in these pictures, is the point where they cross was always really important. So in each of these, that point was marked. These two functions up in the first one never crossed, so we didn't have to deal with that. On the second one, they did cross because the second function was the x-axis. And so we set the two equal to each other, we'd set f of x equal to 0. We'd find that point. And on the third one, the x-axis has nothing to do with anything to do with the area, so we set the two functions equal to each other and we'll get that x value right there. So that's our first step, is to set the two functions equal to each other. If the second function is the x-axis, we set it equal to 0. Then we're going to set up our intervals from that, going, okay, we got to go from A to C and then C to B. And then we're going to test for the upper curve, because we always want to do top minus bottom or upper minus lower. So we're going to set up our intervals and do top minus bottom in each interval to give us a positive number. We're going to integrate. Okay, so those are our 3 steps. And we're going to use those 3 steps to find the area between these two curves. So we're going to do one with these 3 steps, just like we've been doing with the x-axis. I'm just going to call it g of x. And then we're going to do one where that's not g of x. And then we're going to do another one that goes with this. So we're going to pretend to do this completely by hand without a calculator, though I'm showing you the picture here to go along with it. So if we set this up, we've got to find the area between the two curves, our f of x and our g of x. We're going to set them equal to each other. So 0 equals 3x cubed minus x squared minus 10x. Now I'm going to go ahead and factor out an x. Get 3x squared minus x minus 10. And let's factor again, and we get 3x and x. And we go minus 2 plus 5. And that does it. We get a negative 6 and a plus 5. Alright, so our answers are going to be x is 0, 2, and 5/3. Alright? Negative 5/3. Alright, so then we have to check up, because they've got to give you an interval or some other information. So they did give us an interval from -1 to 4. So only 2 of these are applicable, because negative 5/3, thank goodness, is not our interval, because I don't want to do negative 5/3 by hand. And if you can look over on the picture, I graphed it and showed you, there's where we cross, if this is f of x, and then this is g of x. Okay, there's the 0, and then here's the 2. Alright, and so we're trying to find the area between the two curves. So between f of x and g of x, that's that area, and that area, and this area. And I know you can't see all of how high f of x goes. That would require me to have a much higher window on my calculator, but it goes up pretty high. So that goes all the way up, wherever that is. But it's between that curve and g of x. And so I want to be able to show you how to do this completely by hand without that calculator. But we know that from 0 to 2, f of x is on top. And then from negative 1 to 0, f of x is on top. From 0 to 2, g of x is on top. And from 2 to 4, f of x is again on top. So if we're doing this by hand, we have to establish our intervals and test for the upper curve. So we're going to do that like we did with maxes and mins. So our intervals, we got negative 1 to 4 because that's what's given, and we're going to put 0 and 2 in there. And we got these numbers from the f of x function, right? And so if we go ahead and plug in a negative 1/2 here to our factored form, we get a negative, and then negative 1/2 times 3 is negative 1.5 plus 5, that's a positive. And then negative 1/2 minus 2 is another negative, and we get a positive value. And so what that's telling us is that f of x is on top, okay? Because the f of x gives us a positive value. Really what this function is f of x minus g of x. It's just g of x is 0 here. Okay, so if we test a 1, we get a little 1 for x, so we get a positive. 1 in here, we get 3 plus 5, which is positive, and 1 minus 2 is a negative. We get a negative, which tells us that f of x is on bottom, because the only way that you're going to get f minus g to be a negative if g is bigger. And then if we plug in a 3, we get positive in there, we get a positive in here, and 3 minus 2 is a positive, and we get a positive. So what this does when we're testing to see our intervals, that this should correlate to our picture, is that f of x minus g of x, f of x should be on top here, and then on bottom here, and then on top there. So we're going to set up our integrals. So we're going to go negative 1 to 0 of f of x minus g of x dx plus, and so this was a negative, and because I want to keep it f of x minus g of x, because I have to integrate this by hand, I'm going to flip my interval and go from 2 to 0 of f of x minus g of x with a dx plus, and the integral from 2 to 4 of f of x minus g of x dx. So if I had a calculator, this would be really nice right now because I could go and plug everything in and it would be great. But since I don't have a calculator, I'm going to have to set this up completely by hand. I'm going to plug in my f of x and my g of x. So I'm going negative 1 to 0 of f of x, which is 3x cubed minus x squared minus 10x, minus g of x, which is 0. So I'm just going to end that. So each one of my integrals is going to look like that. 3x cubed minus x squared minus 10x. And 2 to 4. 3x cubed minus x squared minus 10x. Alright, now I actually have to integrate. Alright, so I'm going to go x to the 4th, 3 over 4, minus x cubed, 1 over 3, minus x squared, 5. And I'm going from negative 1 to 0. And then I'm going to copy that same antiderivative down, and that's the benefit of making sure all your integrals match, or your integrands, what you're taking the antiderivative of, because then you only have to take one antiderivative. Alright, so now comes the fun part with all the numbers. And these numbers aren't too horrible. 1s and 2s and 0s. The 4 is going to be a bit of a pain, but we talked about this the other day about where AP lets you stop. Right? But I'm just going to set up all my parentheses. So these first set of parentheses, this is for negative 1 to 0. This is from 0 to 2. And the last setup is from 2 to 4. And I realize that this is long. Okay? This would not be on a multiple choice question if they were going to make you do this by hand. But a hand one will be on multiple choice question. It'll probably just be a little bit shorter, a little bit easier function. Right? But I want to make sure you see all the setups, and then there's just pluses in between because we're adding the areas together. So this first one, if we plug in 0, yeah, we get 0. If we plug in a -1, we're going to get 3/4 plus 1/3 minus 5. Plug in a 0, you get a 0 there. You plug in a 2, you get 2 to the 4th, which is 16 over 4, which is 4 times 3, so we get 12, minus, if we put a 2 in, we get 8, so 8 over 3 minus 4 times 5, which is 20. So when I go do my 2 over here, I'm going to put 12 minus 8 over 3 minus 20 over there. And if I have to plug in a 4, I get 4 to the 4th, which is 256, divided by 4, which is 64 times 3, which is 192, minus 4 cubed, which is 64, 64 over 3, minus 16 times 5, which is 80. Alright, so if it's by hand and it's on a free response question, you are absolutely allowed to stop here. And you didn't even have to do what I did and actually know what 4 to the 4th is. You can put down 3/4 times 4 to the 4th. Okay? As long as it's numerically correct, it is correct. Okay? And I'm not going to take the time to put this all together, but from here it's addition and subtraction, and you're just trying to get to an answer. But what you want to make sure is that each one of these integrals gives you a positive value. So we're going to go in and check this answer by our calculator, check each integral. So if you have a calculator, this is all you have to know. Okay? You just have to know how to put the integral setup in that's going to give you a positive value. So I'm going to go into my calculator, and I'm going to make sure that my f of x, 3x cubed minus x squared minus 10x is in my y1. And I'm going to go back to my run menu, and I'm going to do a math 9, get my integral up there, and my very first integral is from -1 to 0. Put that over there. -1 to 0, and I'm doing y1. And I'll put dx in there, get an answer, so 3.9167. So that's this first integral. And it's good to check them one by one so that you know each one gives you a positive value. That's what we're trying to do with area. So we don't want to retype this every time. I'm just going to go pick that, change my interval to go from 2 to 0. So I just have to change that bottom number. Then I get 10.667. That's one we were looking at. That's one that was negative to begin with. And you notice I'm writing down 4 decimal places because I have to keep 4 decimal places all the way through until I get to the final answer where I can round correctly to 3. You want to round multiple times. So the last one, I just have to change it to 4 up there. And I get 101.333. Okay, so if I put this all together, I should get 114.917. Let's check this answer. So I'm going to add that to 10.6667 plus 3.9167. Sorry, 115. Alright, so that's my answer. So that's the area between a curve and the x-axis, but we just worked it as a second curve. So I'm going to go back and work another one where I'm going to keep the same f of x, but I'm going to change the g of x around. Alright, so here's my second problem. And so you see the f of x is the same as our first problem, but now the g of x is no longer the x-axis. And the interval is going to be the same. So with this first problem, that was our f of x and our g of x, and we were finding this shaded area. For the second one, it doesn't matter if I didn't draw the x-axis in there at all. This is my g of x, and this is my f of x. So I'm looking at the area between these two curves. So all of that, and all of that, and all of that. And so what gets people caught up is they keep wanting to do something with that x-axis. Well, the x-axis is only important if it is the second curve. If you're looking for the area between the curve and the x-axis. If it's not the second curve, I could erase that x-axis and it wouldn't do a darn thing to the area that I just shaded in. And so what you've got to realize is the x-axis is not important in number 2. It doesn't go with this at all. And so what we've got to do is still in those 3 steps, we've got to set these two functions equal to each other. Because those points right there, those matter. Okay? Because what happens at those 2 points is the only places where they cross, those are the only opportunities that the curves have to switch who's on top and who's on bottom. If they're not crossing, that same curve is going to be on top the entire time. And so that's why we're doing this, is to figure out, okay, are they getting to switch who's on top and who's on bottom? So we're going to set f of x equal to g of x. So 3x cubed minus x squared minus 10x equal to negative x squared plus 2x. So to be able to solve this, we need to set it equal to 0, which means we're going to subtract one side over. So what I'm doing is I'm going to subtract the negative x squared plus 2x. Really, I'm going to add the x squared over, and the x squareds are going to cancel. I'm going to get 3x cubed. X squareds are going to go away. I'm going to subtract the 2x, get minus 12x, set it equal to 0. I'm going to factor out a 3 and an x, and I have an x squared minus 4 equal to 0, and so I get x equals 0 and positive and negative 2. Alright, those are separate, negative 2 and positive 2. Alright, so I get my 3 values. So what I need to point out, first of all, negative 2 is not in our interval, so I just need the 0 and the 2. There they are. Okay, and the other thing I need to point out is right here, what I've done is this function right here is f of x minus g of x. That's what it is. I took my f of x right here, and I subtracted over g of x. I moved that over. Okay, so this function right here is f of x minus g of x. So when I make my little line, go from negative 1 to 4, and I have my 0 and my 2 in here. What I'm going to label this line is where I got these numbers from, which is f of x minus g of x. The same that it was before, my g of x just isn't 0 here. Okay, so if I put in a negative 1/2, I get a negative here, and 1/2 squared is 1/4, minus 4 is a negative as well, so I get a positive. So let's talk about what this means. If this function gives you a positive, that means this guy had to be bigger. F of x had to be larger, otherwise it won't give you a positive number. Well, let's look back at our drawing just to check. F of x is the pink curve right here. Okay, it is on top. Okay, and that's what this little line is telling you. So you won't always get a calculator to let you look at a picture. You have to be able to trust this line, what it's telling you. Alright, so in the next section, because f of x is on bottom, we can see that this should give us a negative. So if we go back through and pick a 1, we get a positive in here, and 1 minus 4 is a negative, we get a negative. And if we go to 3, we get a positive, and 3 squared is 9 minus 4, positive. So that tells us f of x is again on top, which it is. So we're going to go and set up our integrals the same way that we did before. So we're going to go from negative 1 to 0 of f of x minus g of x. And then the second integral I need to flip somehow, but because I want to keep f of x minus g of x, I'm going to again go from 2 to 0. And the last one doesn't need to change, it's 2 to 4 of f of x minus g of x dx. So again, we're going to set this up like we're going to do it by hand. Okay, when you go and plug this in, now you can do it, you can realize what we did above was f of x minus g of x. But if I went and plugged this in fully and I wasn't aware, f of x minus g of x is 3x cubed minus x squared minus 10x minus g of x, which is negative x squared plus 2x. So this is f of x, and this is g of x. So if you actually simplify this, you'd get 3x cubed minus x squared minus 10x plus x squared minus 2x. And these guys would cancel, and these two would combine, and you get 3x cubed minus 12x, which is what we had up before as f of x minus g of x. So if you will realize that that's what you found before, then that's what you're going to put in your integrals. And it's a little bit shorter than having to do this whole mess the entire time. So we're going from negative 1 to 0 of 3x cubed minus 12x dx plus 2 to 0 of 3x cubed minus 12x dx plus 2 to 4 of 3x cubed minus 12x dx. Now we're going to integrate. So the antiderivative is x to the fourth, 3 over 4, minus 6x squared. I'm going to negative 1 to 0. Then that same integral, or antiderivative, for the other two. Okay, so I'm going to set up each one. Alright, so I've got my 3 different integrals set up and ready to go. If I plug in a 0, I get 0. If I plug in a negative 1, I get 3/4 minus 6. If I plug in a 0, I get 0. If I plug in 2, I get 16 over 4 is 4, times 3 is 12, minus 2 squared is 4, times 6 is 24. So I'm going to plug that over here, 12 minus 24. If I plug in a 4, I get 256, divided by 4 is 64. 64 times 3 is 192, minus 4 squared is 16, times 6 is 96. Well, this is a little bit nicer. We only have a single fraction. So let's go ahead and try to work this out. So this guy's going to be 3/4 minus 6, which is 3/4 minus 24 over 4. So I get a negative 21 over 4, but this negative out here gives us a 21 over 4, and that's important. You need to get a positive out of this first integral. And the second one, 12 minus 24, gives us a negative 12, but this negative gives us, again, a positive, so plus 12. And then the last one, we've got to go plus 192 minus 96 should give us, what, 96? And then minus negative 12, so plus 12. So this isn't too bad to add up now. We get 12 and 12, which is 24, and 96 is 120. So 120 plus 21 over 4, which is 120 plus 5 and a fourth. So we get 125 and a fourth. So that's what we should come out with if we put this in our calculator. And so let's talk about how you would put this in our calculator. So the calculator step is right there. Okay, either one of these. Okay, those are identical, and that's what we get to put in. That's where we get to stop working. So the nice thing about this is you can do this one of two ways, or you can do this many, many ways. You can go ahead and type in the 3x cubed minus 12x. That's fine. You can save that as a different function. Another thing you can do is if you look at what I've done in my y1s, and you can do this in any calculator, you define the functions. Okay, y1 is f of x and y2 is g of x. Well, I'm going to come down here, and I've already got something in y3 and y4 for a reason, but I want to define y5 as f of x minus g of x. And I can type in, go ahead and do the 3x cubed minus 12x. Or I can type it in as y1 minus y2. So you don't have to make a separate function for this. You can go ahead and type that same thing into your integral. But I've made y5 equal to y1 minus y2, which will come out as f of x minus g of x, or 3x cubed minus 12x. So when I go back into my integral mode, I'm going to show you this two different ways. So my first integral goes from negative 1 to 0. And I'm going to use y1 minus y2, which for me is y5. Okay, and most of you would just put that in as y3. I just had something I wanted to keep. So it gives us 5.25, which is what I've got. Okay, so I'm going to go back and copy that and go from 2 to 0. Get the 12 that I did get for that term. And the last one should be what? 118 or so? No, not 118. 108, sorry. So I'm going to go last and copy that. Go from 2 to 4. And I get 108. So I've got all my answers. So if you didn't define a new function y5, it's still not hard to do the integrals. So let's say I'm just going to go from negative 1 to 0. I'll just show you this with one of them. Okay, and if I didn't define a separate function as y1 minus y2, I can come in here in my integral, if I can get over there, and I can type in y1 minus y2, and that's an x. And it gives me the same answer. So you are welcome to go ahead and type in 3x cubed minus 12x, or type in the whole mess. This is just a way to keep it a little bit simpler if you've got a calculator. It keeps it a little bit cleaner. You have to type less buttons. It maybe lowers your chance of making a mistake on the button pushing. Alright, so there's area between two curves. Top minus bottom every single time. Right? Alright, so we're gonna do one more fully, but here I just wanted to see, I'm not giving you actual functions, you can't work the whole thing out. If we could write a quick integral that represents this shaded area. Okay, and so if you look at the shaded area, they do cross at a point. Okay, but you have to figure out your interval. Well, your interval goes from 1 to 4. Now 1 is not anywhere where they cross. 1 would have to be given to you. So they can either give you the interval from 1 to 4 for this problem, or they could say in between the vertical line x equals 1 and then where they cross. They cross right there. And so you've got to find the interval somehow, and that's what we're going to do on this next example that we work fully. We're going from 1 to 4, and so if we're doing top minus bottom, there's your top curve, there's your bottom curve. The shaded area, the top is g of x, and the bottom is f of x. And that's as simple as it is. You don't have to write a separate integral because they never change who's on top. In the interval for our area, the blue, the g of x is on top the entire time. Okay. Alright, so we're going to do one more. Fully worked out. So this one says, find the area of the region bounded by the functions given. And so this time an interval is not given. And these are the hardest ones to do because you have to come up with the interval all on your own. And so I'm going to start this off just by showing you the picture. Okay, this is on a graphing calculator. And so you should be able to recognize that the straight line right here is g of x. That's our g of x. Okay, you will have to recognize what functions look like on the AP exam. You're going to have to know what linear is in an equation, what the cubic looks like. Okay, so then this cubic function must be our f of x. And so far, we don't have any area bounded by either one of them. Bounded means it's got to be in between. It's got to be held in. We have to have some kind of bounds. So right now, there is no area bounded. So they gave us a last line, x equals 1. That is a vertical line. Okay, and so if I went and drew that in, it's not drawn on this graph, I would draw in a vertical line right there. Okay, and so now there is an area bounded by these three functions, which means held in between. That is the area that we're looking for. Okay, so we're going to work this completely by hand, but just to show you on this picture, you should be able to write an integral now. Okay, you've got to say, okay, this pink area right here should only be one integral because it never changes who's on top. In the entire pink area, the red is on top. And so what's important is you got to know where it starts. You got to know this number, okay, and you know where it ends. Where it ends, it is x equals 1. That is the ending part of our integral. And so right now, just from looking at this picture, we know that it starts somewhere. That we don't know, but we know that it ends at 1. And that it is red on top, so f of x, minus blue on bottom, g of x, dx. Okay, and then you may ask, well, why the heck didn't you use this last function? Well, first of all, x equals 1 is not a function. It is a vertical line. Okay, it won't pass the vertical line test. But that part right there is part of our interval. The x's are going to be part of our interval there. And so that's where we're going to use that. It's not top or bottom. It's bounding it on the right. Okay, and so the only thing we have to do is find out this number. Well, what happens there is that f of x and g of x cross. And so we're going to do the same thing that we did before. We're going to set f of x equal to g of x and find that number. So we're going to set x cubed minus 2x plus 1 equal to negative 2x. Okay, and so we're going to subtract the g of x over. So if we subtract that over, we're really ending up adding it because we're subtracting a negative. do x cubed plus 1 equals 0. So x cubed equals negative 1, x equals negative 1. And so what I want you to get out of this is, first of all, this thing right here is f of x minus g of x. Because this was our f of x, and this was our g of x, and we moved the g of x over. We subtracted it over. So that's our f of x minus g of x. That's what's going to end up going there. Our x is negative 1 here. Okay, that's negative 1, so that's the beginning of our integral. Okay, but let's say you didn't have a calculator at all. We just found out where they crossed. Okay, and so we know, alright, they crossed at negative 1. That's the only place they crossed. And 1 is the other part that they gave us as part of our interval. And so if they don't cross anywhere else, they can't be bounded over here. They got to be squeezed in between two things. And so we're going to check f of x minus g of x. And if this thing comes out to be a positive, f of x is on top. And if it comes out to be a negative, g of x is on top. So we put an easy number, like 0, and we put it into f of x minus g of x. 0 plus 1 is a positive. That means f of x is on top, which is what we said up above. We said f of x is going to be top minus bottom. It's going to become first. So our integral is negative 1 to 1 of f of x minus g of x. And so we are going to work this one by hand. This one's pretty easy. Okay, so we said f of x minus g of x is x cubed plus 1, negative 1 to 1, dx. Only one integral. Alright, so the antiderivative is 1/4 x to the 4th plus x from negative 1 to 1. Let's do a top minus bottom here. Okay, if we plug in a 1, we get 1/4 plus 1. Plug in a negative 1, we get 1/4 minus 1. And here's where you got to be really careful. Area cannot be negative and cannot be 0. So don't get your head too fast and going, oh, they cancel out. They most definitely do not cancel out. Okay, the 1/4 are going to cancel out, but the 1s do not. Okay, so those are going to cancel out, but we're going to end up with an area of 2. You must get a positive number when you're asking about area. And so this area right here comes out as a positive 2. Alright? So as you're doing your homework, what I would suggest is use your graphing calculator to show you what thing you're looking at, to convince you that you've got the top and the bottom right. But make sure that you can do this work by hand to support it, because if you don't have a calculator, you're going to have to do all this and you can't see a picture. You've got to trust that this works. So use it to confirm what you're doing, make sure that you understand what you're doing, but make sure you can do it all by hand.